Let's start sharing my screen. And in doing that, um, I have a couple of announcements. Today we're going to, oh, this is not you guys. Let's try that again. Today we're going to be looking at a little bit more of permutations, and then we're going to be looking at combinations. I'm pulling some pages out of the virtual textbook towards the end of class, just so we can kind of make sure everybody's got the difference between permutations and combinations. Um, Friday, which is, I think, October 2nd, I will not be having classes. It's not a whole campus thing. It's just a me thing. I'm the college's representative to an organization called Faculty Council of Community Colleges, and I need to go to a 2-day conference for them. It's held virtually, but it overlaps with all of my classes, so there just won't be classes those days. I looked, and in Blackboard, I got a lot of projects submitted already, but if I remember correctly, I thought we had pushed that back to Wednesday because I didn't assign it until Wednesday. And so if you haven't submitted it yet, please do so. Homework 6 is due today. Homework 7 is due on Wednesday, the 30th. Before we get started with anything else, and not many of you took the opportunity to take that extra little one question over the weekend. I think I sent an email to somebody this morning that I want to look at yours for partial credit, but Blackboard is not letting me open the work that you submitted. So if you could please send me your work again via email. Other than that, does anybody, before we get started picking up where we left off, does anybody want to look at anything in my labs? Does anybody have any questions on any of the homework problems? If not, I'm going to see what you can remember from last class. Can anybody remind me what a permutation is?
I wrote down here, arrangement of distinct objects that cannot be repeated and the order matters.
So the objects have to be different.
Yeah.
You can't repeat. And order matters. There is one formula that we will have that kind of contradicts that, and it's the idea of permutations with repetition. And so I want to look at the arrangements of the letters D, O, G. And so they're different. Order matters. I'm using 3 of them. So there would be 3P3, which is 3, 2, 1, or 6 of them. If we were to list them, we'd have D, O, G. We'd have D, G, O. We'd have O, D, G. We'd have O, G, D. We'd have G, O, D. We'd have G, D, O. Is everybody comfortable with that list?
Yep.
What if instead I changed it to arrangements of the letters in the word A, L, L? This one doesn't fit that rule that we had for permutations because we've got two that are the same. We can think of it as two letters that repeat or two letters that are not necessarily distinct. And so, do you think there's going to be more if two letters are the same, or do you think there's going to be fewer if two letters are the same?
Fewer?
Fewer. I'm thinking there's going to be fewer. Let's see if we can list them. I'll do the first one, the hard one, A-L-L. How else can you arrange the letters in the word all?
L-A-L.
L-A-L. Anything else?
L-L-A?
L-L-A. Anything else?
I think that's it.
I think that's it too. And so if there are repeats, we have fewer permutations. And the way that we get that there are fewer permutations, the way we get a smaller number is by division. What the rule says is if there are n objects, R are the same, S are the same, T are the same. And I'm going to put a dot, dot, dot because we could have more things that repeat. There are n factorial. That's how many we would have if they were all different. But then if S repeat, we have to divide by S factorial. I'm sorry, I took that out of order. I apologize. If R repeat, we have to divide by R factorial. If S repeat, we have to divide by S factorial. If T repeat, we have to divide by T factorial. And if there are more repeats, we have to divide by more factorials. So I'm going to move the class for a minute, and I'm going to see how does that pertain to our word all. In all, there were 3 letters, so that's 3 factorial. And how many letters repeat? There's 2 L's, so we'll divide that 3 factorial by 2 factorial. And so working it out, that's 3 to 1 over 2, 1, which gives us the idea that there were 3 repetitions. So if one thing repeats, okay. So what's the whole thing with the RST? Can I turn the page? Everybody all right?
Yeah.
Did I ask for the arrangements of the letters in Mississippi? M-I-S-S-I-S-S-I-P-P-I. So is it obvious here that more than one thing repeats? And so what we need to do is, first of all, we have to do a factorial for all of the letters. And so how many letters are there in Mississippi?
11.
So that gives me 11 factorial. And then what letters repeat?
S and P and
S.
I,
How many I's are there?
3.
I think 4.
4.
Yeah.
Oh yeah, 4,
How many
sorry.
S's are there? How many S's?
4.
How many P's?
2.
2.
2.
And so we would have to work that out. When you do this, if you use your calculator,
I got a question.
sure enough,
All right, what's this above like the 4 and the 2? What is this?
because not all of the letters are different, there's 4 letter I's. So that's where the first 4 comes from. There's 4 letter S's, that's where the second 4 comes from. And there's 2 letter P's, that's where the 2 comes from.
Yeah,
So
yeah, that where you just drew the arrow to. What's that?
there's 11 letters altogether.
Oh, that's at 11. Okay, I just wasn't sure what it was.
Okay, sorry about that.
Yeah,
In my next life, I'll try to get better penmanship. Okay, so if you're going to do this with a calculator, you have to be careful of the order. So we're going to take 11 factorial, and when you look at order of operations, what you have to remember is there are an invisible set of parentheses around the denominator of a fraction. And so if I were to type this into my calculator, I type 11, then I type my factorial, then I do my division. Actually, let me write that as a division symbol. Divided by, for the bar and the fraction, then I hit the parentheses key. Then I type my 4 factorial, 4 factorial, 2 factorial, and close the parentheses. And so when you do that, what do you get? I'm getting a little bit of feedback from somebody. I hate asking, but if you're not speaking, could you mute to kind of cut down on the feedback? What are you guys getting? Are you still typing it in, or are you just not brave enough to give me your answer? Is anybody else getting 34,650?
I guess.
Yeah? Okay. Now, I want you to try typing that in again without the parentheses. Without the parentheses, are you getting the same answer? Without the parentheses, you'd be taking 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. In order of operations, you'd only be dividing by the 4. Then you'd be multiplying by the 2, the other 4 and the 2. And so it gives you a much different answer. Is there anybody who'd like to see how you would get that by hand?
Mhm.
Yes.
By hand, 11 factorial is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In the denominator, 4 factorial is 4, 3, 2, 1. 4 factorial is 4, 3, 2, 1. And 2 factorial is 2, 1. And then I'm going to do some old-fashioned reducing fractions. 4, 3, 2, 1 would cancel. Then I'm going to say that 3 times 2 is 6, so I can cancel out the 6. Then I'm going to say that 4 times 2 is 8, so I can cancel out the 8. And what I'm left with is 11 times 10 times 9 times 7 times 5. And so I think that gives me 990 times 35. And I am hoping that that also multiplies to the 34,650. Okay, do you have to do it by hand? No. If you're doing it by calculator though, make sure to include those parentheses. So let's do a couple more examples.
Sorry to interrupt, I'll be right back.
Okay. What if I had instead the word happy? How many letters do we have in the word?
5.
5. So if they were all different, there'd be 5 factorial. Are there any repeats?
Yes.
Yeah.
What repeats?
The P.
And how many P's are there?
2.
So this is going to be 5 factorial over 2 factorial. Anything else repeat?
Mm.
And so when we work that out, 5, 4, 3, 2, 1 over 2, 1. Is anybody else getting 60?
Oh.
I actually like doing it by hand. I think it's a lot easier.
Then do it by hand. That's perfectly
Yeah.
fine. I actually sometimes find it easier to do it by hand because at some point in time, I get sick and tired of typing in a calculator. And sometimes on my calculators, if I don't hit the buttons hard enough, they don't register and it, messes everything up. Let's do one more. Let's look at the word engineer. How many letters are there altogether?
8.
So that's 8 factorial. Do any letters repeat?
Yes.
1.
What letter repeats?
E.
E.
E. Anything else repeat?
N.
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 And so do you see why we need 2 factorials in the denominator? Because there are 2 distinct letters that repeat. And so you can do it by calculator or 8, 7, 6, 5, 4, 3, 2, 1 over 3, 2, 2, 1. I guess I'll put my 2 into the 8. And so that gives me 28 times 120, which I think would give me, I'm going to be lazy and pull out my calculator.
3,360.
160. And so this idea of permutations with repetition, all right. If some of them are the same, technically they're not a permutation, but we've got this formula that we can use. Okay.
Wait, where did you get the 28 and 120 from?
4 times 7 is 28. 6 times 5 is 30. Times 4 is 120. I just did a little bit of multiplication in my head. All right.
Okay.
Otherwise, if you don't want to do any of that in your head, think of it as 8 factorial divided by, open parentheses, 3 factorial, 2 factorial equals, and you should get the same results.
Okay.
Okay? If that's all right, we're kind of going to set permutations aside till a little bit later, and we're going to start looking at combinations.
Before we set permutations aside, can we go over how to do it in the calculator again? Because I don't remember that.
Okay, so on my calculator, I wish there was a way of sharing my calculator. You know
Yeah, I
what?
just forgot where the factorial button was.
Okay, so
Yeah, that's
on
what
my
I'm saying.
calculator for that one, I'm going to press 8. And then in order to get to factorial, stare at your calculator for a minute.
Mm-hmm.
The chapter we're in is probability. Do any of the buttons look like it might be shorthand for probability? The PRB button?
Yeah.
So I'm going to go into the PRB button. And then when you go into the PRB button, you have a couple of
I've
choices.
got a graphing calculator.
Use the arrow over to get that factorial.
Okay.
Now I've got the 8 factorial divided by parentheses. I'm going to go 3 probability factorial and then 2 probability factorial. I'm going to close my parentheses and voila, I got the same answer.
I don't have that button on my. I have
Okay. Show me, I'm going to stop sharing my screen for a minute. I'm going to ask you, I'm going to go to speaker view. Oh, okay, all right, you've got a grapher. So with the graphing calculator, what you have to do first is you have to first put in the 8.
Put in the 8.
Yeah, type
Okay.
8. And then
All
we're
right.
in math class, so press math.
We're in math class. All right.
And once you press, oh, you know what? I haven't done it with a grapher in a while. Let me make sure. Once you're in math, there across the
Oh, I
top,
found it.
arrow over to the PRB.
Yeah, I got it. Appreciate
Okay.
it.
All right. So just remember we're in math class.
All
Okay.
right. Thank you.
Then everybody else all right? Getting that from their calculators. If so, let's go on and look at combinations. Combinations are arrangements of objects. The objects have to be distinct, which means they're different. I can't repeat. But this time, order does not matter. And what happens is if order does not matter, it's again going to be a smaller number than permutations. And the way in which we're going to get that smaller number, again, is to divide. So we're going to say that NCR is the number of combinations if you pick R objects from a group of N. And so realize that's saying that R is going to be less than or equal to N. It's the smaller number. And CR, the definition that I learned when we did it all by hand was NPR over R factorial. The definition that Mr. Blitzer gives is N factorial over N minus R factorial. That's our NPR. And then a second R factorial.
For the definition, is that supposed to say combinations, not commutations, or?
Oh
I don't
yeah,
know.
I misspelled it. COM, I just missed the letter. BIN. I'll erase it and redo it. Better? Let's say class has 22 students. How many ways can I pick 3 to work together? On a problem. So let's see. Is everybody in class different?
Yes.
If I'm picking people, 3 people to work on the same problem, I'm not going to have the same person work on it twice. I'm going to pick different people each time. I'm not going to repeat. Now, if 3 people are working together, think about it. If I work with you, is that any different than you working with me?
No.
It does not matter. And so this is going to be 22 combination 3. And so by hand, I think of that as 22 permutation 3 over 3 factorial. Or when I do these by hand, I take the smaller number factorial, and then I start with 22. and I work until I have the same number of factors. And then you can work that out by calculator or by hand. I'm kind of old school, so I'm going to do it by hand. And so 77 times 20, I believe, is 1540. If we were to do that using Mr. Blitzer's definition, 22 combination 3 would be 22 factorial over 22 minus 3 factorial, 3 factorial, which would be 22, 21, 20, what comes after 20? 19 down to 1 over 22 minus 3 is 19, so that'll be 19 down to 1 times 3 factorial. And you see, once I cancel that other part out, I get the same result. If anybody thinks that's too much writing, the other way is to use your calculator. And with your calculator, when you look at that, you're going to type your 22. When you look at that probability menu, there's a place where you can move to underline NCR. Then you're going to type in your 3. And voila, you get the same 1540. Everybody all right so far? I'm going to ask you folks to do a few combinations for me. Oh wait, I forgot something. There's an exception. Any number combination 0 will always be 1. And now I want to ask you folks to look at a couple of patterns for me. I want to look at combinations of, oh, I don't know, let's look at the number 5. So I want to find 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, 5 combination 5. And I'm going to shut up for a minute and give you folks, about a minute in order to find the values of those 6 combinations. Whether you do it by calculator or by hand is up to you. We at the go over place, anything combination 0 is 1, 5 combination 1 is
120.
5 combination 1, I think it's just fine.
Oh, I probably put it in wrong.
Double check, make sure you get it.
Oh.
5 combination 2 let's see, that would be 5 times 4 over 2 times 1. So I think that's 10. 5 combination 3 is 5 over
15.
3 over 3 to 1, which is 10. 5 combination 4 is 5, 4, 3, 2 over 4, 3, 2, 1, which is 5. 5 combination 5 is 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1, which is 1. Does anybody notice anything about the answers?
They're all pretty small numbers.
Yeah, they're smaller numbers. Anybody notice anything else?
They're
They
divisible by 5.
These ones are divisible by 5. Does anybody notice a pattern though?
They
Yeah, it goes up and
repeat.
down.
They repeat, right? The first and the last, the second and the second to last, the two middles. And I want you to look at the ones that are the same. If I look at the ones that are the same, 0 plus 5 is 5. 1 plus 4 is 5. 3 plus 2 is 5. And so that gives us the idea that n combination r is the same as n combination n minus r. So what the heck does that mean? Let's say, for example, I want to find 100 combination 98, and I don't have my calculator with me. Well, 98's too big for me to think about doing without the calculator. So I'm going to check and see 100 combination. If I take 100 minus 98, what do I get?
2.
2. And 100 combination 2 isn't too bad because that would be 2 factors starting with 100 over 2 factorial. So that would just give me 50 times 99, which would be 4950. And so it's not something that is like super important for you to memorize, but if that second number is more than half and you're doing your computation by hand, you can keep the number smaller by taking the difference. All right?
Yeah.
Just an interesting aside. And so where we're going next are probability problems. And with probability problems, one of the things that sometimes people find a little bit more challenging is trying to decide, hey, wait a minute, is it a permutation or a combination? Does order matter or not? Oh, I didn't give you guys my bad joke. Well, it's not really a joke. Anybody here ever use a combination lock? With a combination lock, when you've got your numbers, does the order in which you put them in matter?
Yes.
Yeah.
So shouldn't they be called permutation locks and not combination locks?
I guess. It's not,
Okay. Yeah. Think
not
about
easy
it
to
for a
remember,
minute.
though.
Think about it for a minute. All right. So what I'd like to do is look at some problems. Hopefully this is still here for me. The virtual textbook. Is it still there? No, I'm going to have to reopen it. And have you guys help me decide if something's a permutation or a combination and figure out the value of it. Oh, poopers. This is what happens when I try to get prepared in advance. It's making me go through and do it all over again. I apologize. This would be, if we were in the classroom, this would be the time where I would be fumbling to get my paperback textbook to balance underneath the document camera. So it probably takes about the same amount of time. And you're going to find some questions in this homework that do this. And while I'm waiting for that to come up, going back to the first screen, I forgot to mention on Wednesday, there's going to be a quiz that involves counting, permutations, and combinations. The
This
quiz
Wednesday?
this Wednesday, it'll be in Blackboard. It'll be available after class till the end of the day. Thursday, you only have one shot at it. You can use a calculator to do computation, but you need to know when you need the counting principle, when you need permutations, and when you need combinations.
Okay.
Okay, let's see. Is this book up yet? Yeah, it is. It's coming. Why is it? There it goes. Has anybody used the virtual textbook?
Yes.
Yes. Is it helpful?
Yes.
Sometimes, yeah.
Good. Good. Okay. So, I got to move everybody again. Actually, let me make these bigger first. Can you guys read that or no? Does it need to be bigger?
I can read it.
Read, okay.
You can read it?
Yes.
Yeah, I can read it.
Okay. So for 29 through 40, what we're supposed to do is, oops, no, those ones we know that they're combinations. So let's look at a couple of them. Let's look at 36. I'm sorry, it's bouncing. 36 says, to win the New York State Lottery, one must correctly select 6 numbers from 59 numbers. The order in which the selection is made does not matter. Okay, has anybody in the room ever played lottery? When you're filling in your lottery card, they don't care what order you pick the numbers in, so order does not matter. And so this is going to be a combination. There are 59 to pick from, and we want to choose 6. And this is one where I probably would not try to do it by hand. So if we look at 59 combination 6, you're getting, oh my heavens, how many different ways are there to pick those lottery numbers? Is anybody else getting 4, 5, 0, 5, 7, 4, 7, 4, or 45 million? Wow. Lots of different combinations. Then let's look at 38. Does anybody want to read 38 to me?
Where's 38? Oh. How many different committees can be formed from 5 professors and 15 students if each committee is made up of 2 professors and 10 students?
Okay, so there's a lot going on here, isn't there?
Mm-hmm.
You have to pick the professors. And again, if I'm working on a committee, if I'm on a committee with you, that's no different than you being on a committee with me, so order does not matter. We've got 5 professors and we want to pick 2. Is everybody comfortable that with being 5 combination 2? Okay. What else do we have? We have 15 students and we want to choose 10 of them. What would that look like as a combination?
15C10.
15C10. And now the magic word in between there is and. The counting principle says that if I want to pick professors and students, isn't it the number of ways I can pick a professor times the number of ways I can pick the students?
Okay.
And so here we've got does everybody see the need in this wording for two different combinations? So 5 combination 2 is 10. 15 combination 10 is, what are you getting?
I got 3,003.
And so when we multiply by the 10, we get 30,030. Oh,
Wait, no.
Three
The
zero
15
zero
combination 10 was
three
3,003.
yeah.
I
And
misunderstood what you were asking.
combination 2 is 10.
Oh,
And so the difference, if I could only write, is 30,030, the product.
okay.
And so does everybody see the need with that one of doing 2 of them?
Yeah.
So now I want to skip down to 41 through 60,
Okay.
because here we're not told what it is. And so I want you guys to help me decide, is it a permutation or a combination or the counting principle? 41 says, in a race in which 6 automobiles are entered and there are no ties, how many different ways can the first 4 finishers come in?
That's permutation
That's permutation.
because
Yeah.
the order matters.
Order matters, otherwise we wouldn't be running a race, driving in a race. How many are there to pick from?
6.
And how many do we want to pick?
3. Oh, no, wait.
How
To the
many
first 4.
First
Sorry.
4.
So 6 permutation 4.
Mhm.
What are you getting?
4.
I got 360 on my calculator.
I got 360 by hand. Did anybody else get a different number, or are we all good with 360? Next one says a book club offers a choice of 8 books from a list of 40. In how many ways can a member make a selection? So we're trying to decide, we've got 40 books to pick from, and we're going to buy 8 of them. When we select the books, does the order in which we choose them matter?
No.
No. So will this be a permutation or a combination?
Combo.
Combo. How many
Combination,
to
yeah.
pick from?
40.
Picking for 40 books.
We have 40 books and we want to choose 8. So this one, everybody all right with why this one is a combination?
Yeah.
And is anybody else getting a huge number from their calculator? I'm getting something like 76,904,685 ways of doing it.
Yeah.
Wow. No wonder it takes my daughter-in-law so much time to pick out books. She's a reader. Everybody all right so far? I'm going to clear these then. And I'm going to go to the next page.
I mean, that will take a moment. Just let you know, we only have like 2 minutes. I noticed.
Let's pick a couple more and see if we can decide whether order matters or not. Let's say, let's look at 46. I have no idea why. 50 people purchased raffle tickets. There are 3 winning tickets are selected at random. Each prize is $500. In how many different ways can the prizes be awarded? If the prizes are all the same, Would it make a difference to you if you got the first one, the second one, or the third one?
No.
No.
So is everybody all right? This one would be a combination,
Hmm.
and we'd have 50 people choose 3. Let's skip around a little bit. Let's look at 50. Oh, let's look at 50. Baskin Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? You pick an ice cream. You get to pick 3 flavors in a bowl, 3 scoops in a bowl. If the 3 scoops are going to be next to each other in the bowl, does the order matter?
No.
No.
Is everybody all right? This is a combination. We
No.
have 31 choose 3. Let's say I'm going to clear. Do we have time for one more, or are we done?
I'm at 10:50 now.
Okay, I'm guessing we're done. Go through, look at some of these. You know, the thing you have to ask yourself is, does order matter or not? All right?
Okay.
Okay. That having been done, let me change my finger back into a mouse. Let me exit out of this textbook. Let me, where's the thing to tell me to stop sharing? There it is. Stop sharing. Let me stop recording.